So, forces of attraction in solids are relative, meaning comparatively speaking. So, iodine and solid CO2. So, dry ice is what that is. They can sublime. So, they have weaker forces. They have pretty weak forces. Can sublime, right? Solid to gas. Steel, for example, doesn't sublime. Salt doesn't sublime. They are much stronger. Much stronger than iodine and CO2. Okay, so it is all kind of relative. And what do you think plays a role in how strong they are? It's how tightly packed they are, and how strong their attractions for each other are based. There's a lot of little details, but basically it's how they're arranged. So solids are arranged in a regular, repeating crystalline structure. So those words are just good to kind of read a couple times to yourself to get them to stick in there in your brain. Regular, repeating, crystalline structure.
CO2 can sublime?
Yeah, I really butchered that word. Sublime. Yeah. Undergo sublimation. Sublime. Do you own that t-shirt? Do you own that t-shirt? No, Sublime. It's another band from the 90s.
No.
Sorry, took you off guard there.
If you blasted a certain solid that didn't sublime with enough heat, could it just...
Like enough heat at once?
Yeah.
Yeah, you could vaporize it, sure. Yeah. In fact, diamond is really, 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 really strong, but at one point when it gets hot enough, it actually doesn't melt, it vaporizes.
Is that what happens on...
If iodine is weakly packed together, is it possible to pack it together tighter?
You have to increase pressure,
Okay.
cool it down. Those two things would help. So, regular repeating crystalline structure. If I say crystal, Rebecca, what do you think of? I say crystal.
Like rock.
Rocks, good. What else do we think of?
Sugar.
Sugar. Okay, what else?
Shiny.
Shiny stuff.
Diamonds.
Diamonds. I think of chandeliers. I think of like
Strong.
fancy crystal stuff like maybe older
That
people would
thing.
have in their house, like the
I
drink
was
house.
just thinking of
Jewelry. What thing?
Yeah.
the shiny
thing.
salt lamp.
Oh yeah. Okay, good. Now, so that's normal, like to think those things. In chemistry, crystal doesn't necessarily mean that. So a lot of solids, like think of metals, think of salt, sugar. If you were to zoom in and look at their structure, it would look like this. Regular repeating means there's a geometric pattern that repeats over and over and over. So when you see a bunch of atoms that kind of like how we would draw a particle diagram of a solid, and you can just watch, you don't have to draw this. That's called a crystal. It's actually called a crystal lattice. I like some lattice in my salad.
Well,
Salon. What is a salon?
So, I get that reference, but anyways, what's a lattice? Anyone know what lattice is?
Yeah, it's that stuff that you put underneath your porch.
Yeah, under your porch or under a deck. It's like the crisscross
It's the wool
pieces of
thing.
wood.
Oh, yeah.
Supporters.
No, it's usually just for like,
It's
Decoration.
just for
Decoration,
decoration.
something.
Oh, yeah.
yeah, I mean you could, sort of. I mean it's not like you could run through it very easily if you could. But anyway, the point is,
But it like won't hold it up.
no, it's not structurally sound. So anyways, if you don't know what lattice is, I'll throw a picture up tomorrow and show you. But that lattice structure repeats over and over and over. That's why this is called crystal lattice. So if you had salt, let's say, or let's say steel. No, let's say iron. So let's say this is iron, and these are all atoms of Fe, iron atoms. So if you had, this isn't iron, but if this was made of iron, this would be, actually I don't think it is, but I would have literally like trillions and trillions of these repeating in the same pattern. All right, so, or imagine if this entire floor had basketballs in a single layer packed in. That's what that would look like. You with me?
Yeah.
Imagine if we were hovering and this entire floor was covered with basketballs or any beach ball, golf ball, whatever ball you could, think of, softball, whatever, okay? It would look like this. That's called, in chemistry, crystal. That's the crystal structure. Because it's three-dimensional, so if you take that and now you start putting basketballs on top of basketballs, it becomes three-dimensional, and that shape actually is like a little cube. It's called crystal unit cell. So in chemistry, we say crystal, this is what I mean. I don't mean diamonds and crystals like in rocks or, but the reason diamonds have the edges and angles they have, or rocks do, or that thing over there does, is because of the way the crystal is built. It's pretty complex, so I'm going to leave it alone at that. But this is called crystal lattice, and this is what a lot of solids look like. Now, this is iron. You guys know what steel looks like?
A little bit.
Isn't it iron and carbon?
Very good. It's iron and carbon. What happens is you put the carbon here. So again, take our analogy, floor is full of basketball. There's going to be diamond shapes, right, in between. So here is going to be a space. So if you put all the basketballs on the floor, they can't fill up all the space, correct?
Right.
Those spaces are filled with a smaller atom, like carbon. The black ones are carbon, and that's what steel is. Steel is 96% Fe, 4% carbon. That's what steel is. What's the type of steel that doesn't rust? Stainless steel. And what happens is they put a layer around the iron that does not oxidize very well. And that's how it becomes stainless. Like chromium, for example, doesn't really rust very well. But anyways, that's what crystalline means in repeating and regular. We're not done yet. Now, I'm going to leave that up there. You guys know what this is. Write this down. Amorphous solids. Still got a couple minutes, we're going to use it. An amorphous solid is a solid with gaps in the crystal lattice or crystal structure, and not as organized. No. So if I take these and I kind of just start mixing them up and they look all kind of swirly, and I take one out, that's what an amorphous solid looks like. It's like rearranging or mushing it all together so there's gaps and it's not neat order. It's not regular and crystalline anymore. It's all kind of messed up. We got a couple minutes.
It's like Play-Doh with an
Oh,
air
okay,
bubble in
good.
it.
Play-Doh. What else?
Clay.
Slime, clay. What else?
Clay.
There's three big ones that I want that the regents may bring up. So, one of them, you're on top of it every day.
Dirt. Magma. You're on top of it?
You're on top of it every
Floor.
day. You ride on top of it every day. Rubber. And what's the rubber on top of?
Metal.
Clay.
What do we drive on?
Pavement.
Pavement, asphalt.
Oh.
Asphalt. Asphalt. These are solids, but they're not as hard as like steel, for example. And the other one you can see through.
Glass.
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 You ever see really, really old windows in a house or a barn or something?
No.
What do they look like? Anybody?
Dusty.
They're kind of wavy. Thicker in some areas than others. Some people try and say glass is a liquid because over time, the glass can kind of settle, so the bottom tends to be thicker than the top on really, really old windows. And it's not because it's a liquid; it's because it's one of these. There's only one more. We did it in lab. We melted it.
Sulfur.
Sulfur.
Hey.
Sulfur becomes very pliable and plastic-like after you froze it again, right? That's because it's an amorphous solid. All right.
Right.
Good job.
I took video today.
Yep.